Okay, first of all, thank you all for joining our webinar today on the title of the advantages of using MBR in wastewater treatment system. So now it's 3:05 p.m. I think the participants coming in as well, but we will start our webinar session first. Yeah, so before this, please ensure your speaker is mute to ensure the smooth presentation from the Dr. Roy. So if you have any question about this webinar, you can ask inside the chat room and we will answer it after the Q&A section, during the Q&A section, sorry. So any supporting material like handout, the Excel package for simulation and the related journal paper will be sent after this webinar. So without further delay, I would like to invite our director, Mr. Chiu, to have an opening speech. Welcome, Mr. Chiu.
With guest speaker, Professor Dr. Muhammad Roy Bilal, participants and partakers. It is a glorious moment to extend my warm wishes and welcome all of you on behalf of Spectra Tech for today. Spectra would like to take this opportunity to say a big thank you to all your supports for these years. And I'm aware that I also believe that some of you, the participant, has been our client since day one. Honestly, we are really proud and also appreciate. Okay, for being part of the participant appreciation to you all, Spectra is sincerely organized today webinar to share our experience and knowledge that is beneficial to water treatment industries. I would like to convey my heartfelt gratitude to Dr. Muhammad Roy Bilal, Professor at Chemical Engineering from University Technology Petronas, accepting our invitation today. Professor shared his value, experience, and knowledge over the webinar on the advantages of using membrane bioreactor in wastewater treatment plant. Let me just introduce a little bit about Professor. Actually, Professor has 16 years experience in MBR study and more than 130 scientific publication on the MBR. Professor is the inventor for 3 technologies on membrane fouling control in MBR. Professor also provides consultation to improve treatment plant performance, including for this wastewater treatment and the wastewater reuse or recycle system. Listen carefully, it's water recycle system. Okay, so Spectra actually has been collaborating with Professor since the beginning of year 2020, and unfortunately during the March, there's an MCO coming. But even though there's an MCO, we still working very closely to each other. So actually, Spectra not only have this engineering team to design, to build, and to commissioning the plant for the MBR. And we also have this academic support from Professor in design of an MBR, in operation of the MBR. For today's seminars, Professor will view on the advantages of using MBR in wastewater treatment system. And I hope that it will become a piece of beneficial information to add to our knowledge. Today, he will cover 4 scopes. So the scope of this seminar, I would like the professor to share with you later. And I would like to take this opportunity to thank Professor, Ms. Fong, and Elvis, and the organizing team for their diligence to make this webinar happen. I'm quite sure this seminar will provide you all with many additional new ideas and informations. Last but not least, thanks all the participants today. Without wasting the time, I would like to pass this session to Professor to proceed the seminar today. So I wish all of you have a very fruitful webinar and enjoy for today. So Professor, I pass this session to you.
Okay, thank you for the kind introduction, Mr. Chu. Hi everyone, I'm very honored to be here to share my experience on membrane bioreactor. I hope the information will be useful, and probably you will start to consider adopting the technologies because of many advantages. So in addition to the slide I'm presenting here, later on you will be provided with handout. I also provide you Excel package for simulation that I will demonstrate during my talk. And then, well, I don't speak in a common term. Many of the statement I put here based on references, so all references used in this presentation also attached to the handout. Okay, so the outline of my presentation, I will start with the overview of bioreactor process. It is just to refresh our understanding because sometimes we are busy on something and we forget about the fundamentals. Just a brief slide. Then we'll go on to how the activity sludge process works and how it is upgraded to become an MBR. And upon upgrading the activated sludge to membrane bioreactor, there are many benefits. So almost half of the things here, slide I present here, will show you the benefits, not only by stating the findings, but I also will demonstrate to you through a basic simple calculation. So I'm going to also highlight a bit of how, if we would like to further reuse the effluent of the wastewater treatment, which is otherwise now probably discharged to the water bodies. And I will make a few cases comparing the conventional activated sludge with MBR. How the design will look like when we use it for domestic wastewater treatment, for industrial wastewater treatment, and some of the important things or remarks if we try to retrofit or upgrade the current activated sludge system to membrane bioreactor. I will then end up with conclusion and recommendation. So biological process, if you make it as simple as possible, this will be the reactions. So we have wastewater. What is wastewater? It's water plus organic pollutants. We need an oxygen for the microbe to breathe. Okay, I'm making an alignment term. And then because of that one, we will digest the organics to form carbon dioxide, water, and other metabolites. On top of that, we also produce more cell. In this case, we call it sludge. This picture gives you a basic illustration of how actually the big one here, chunk here, is basically the living things. They use to uptake the food from the organics as well as the oxygens. Okay, so the microorganism will consume the organics from the wastewater and they will use the oxygen for respiration. And then we have a different kind of those microorganisms. I won't go into detail, but this basic understanding is translated into the design of the conventional activated sludge. So how this look like? We have the biodegradation part where actually this reaction happen. And then to be able to have a clear treated water, we need to separate the cell to the treated water. So we have basically two parts, which is the biodegradation in the bioreactor. Here, aeration is used to provide the oxygen. And the sludge that we produce, we also have to take it from the system. So in here, wastewater and air to provide oxygen. Out is basically we have some CO2 there. It's not shown here. We have a treated water and we have an excess sludge to process later on. Okay. Although it has been well established, okay, the activated sludge process has inherent limitation. Okay, to be able to allow the degradation and the separation well, we need to operate the system under favorable condition for growth and sludge for separation. If not managed well, one of the most often cases, we call it sludge bulking. What is sludge bulking? Normally in this clarifier, we want to be able to easily separate the treated water and the sludge. But when your sludge is bulking, this process doesn't work. And how it is look like this one. You see here, instead of producing clear effluent, you produce a muddy-like effluents. One of the reasons why this happens is because of the overgrowing of, they call it as filamentous bacteria. So when we look into the limitation of the secondary qualifier, operating activated sludge is sometimes a headache. It's not easy. We have a limited flexibility to operate the system. For example, we cannot suddenly change the feed loading or the organic concentration, and then it is highly sensitive to feed variation. Also, maintaining the sludge settling is very challenging. Okay, so if it's applied in the full if applied in the full treatment, the conventional method consists of three things. We start with primary treatment when we settle some of the solid in the raw wastewater, and then the settled solid goes to the secondary treatment, which we call as activated sludge. And sometimes, just sometimes, when the quality doesn't really meet the standard, we need to do some post-treatment. For further clarification, can be through activated carbon filter, can be using membrane filter, or can also include a UV exposure of chemicals or chlorine dosing for disinfection. What MBR does is basically we employ ultrafiltration or microfiltration to replace this unit, sedimentation tank. And what is done when we replace the sedimentation tank with the membrane filtration, we get the whole of this. Instead of getting only the secondary treatment, we will also have a effluent quality that meet the combine of the secondary and tertiary treatments. And there are many advantages that I will discuss later on. So there are so many different configuration of MBR. For example, here on top, it's called as a submerged MBR on separate tank. So basically, we place the membrane in the tank here, and then we use pump to draw the permeate. So this is submerged configuration. We can also have a side stream configuration where we use a cross flow velocity. And here other configuration is we use side stream with airlift. Airlift is basically we use air to promote the flux. Okay. Detail on MBR and operation, I will not discuss today. Might be off a topic for the next talk if someone interested. I will focus on comparison in this talk. So, what are those advantages of putting membranes to activated sludge? In terms of engineering, we will have smaller footprints, mainly by eliminating the need of clarifier. In terms of engineering-wise, when we want to implement MBR, we don't have to start from scratch. Okay, we can simply use the existing water treatment system and do process upgrading. Okay, in doing so, we will not only increase the quality of the effluent, but we will also be able to increase the treatment capacity. Okay, in terms of wastewater treatment, MBR offer constant and excellent effluent quality, even when the feed is fluctuating. Okay, the system have a very good buffer to be able to handle feed with variable effluent qualities. On top of that, normally zero suspended solid. So because of the thanks to the membrane that retain all of the solids, it's also perform disinfection. Basically, because of the size of the virus or microorganism is much larger than the pore size of the membrane, so the membrane will be able to eliminate the need of disinfection unit. So basically, you don't need to do a chlorine, you don't need to to apply ozone if required. We also don't need to apply UV treatment when we have membranes. Another advantage is it will be significantly reduce the excess sludge. I will discuss in detail later on. And then the quality of the effluent is so good as such, it can directly be used. Okay, well, of course, that's depend on the application. But for the process application, then if you want to use it for process, we will need a simple post treatment, can be using an RO or other unit. I will discuss a bit about this one later on. In terms of plant operation, MBR is simple and flexible because of I don't know this term is familiar. We can decouple what we call as a solid retention time and hydraulic retention times. Then which is otherwise very difficult to do in the conventional activated sludge. We have no problem with sludge bulking. In fact, there are many reports indicating that sludge bulking is better in enhancing the effluent quality when it happens in MBR, and suitable for remote monitoring. So, of course, this one is depend on the level of design you want. But currently, some of the new developed MBR can be monitored through the apps in the smartphone, because we link the membrane performance to a software, and then it's directly send the data to the user that you can monitor online. Okay, because of those advantages, you see this data is coming from this paper. I will share with you later on. You can see the exponential increase in MBR capacity worldwide. You see here, this is only capture the super large MBR that has a capacity of more than 100,000 cubic meter per day. So you see the increment here is exponential. In terms of academic wise, also the research on MBR is hot. I mean, and then there are also exponentially growth number of technologies patented related to MBR. In this slide, this image, I show you application of MBR with a capacity of above 10,000 cubic meter per day. We can also see the exponential growth of MBR application, not only for municipal is the blue color, but also for industrial wastewater. You see, even for industrial wastewater, the increment is way higher than the others. So it begs questions. Why then the acceptance of MBR is so good? As such, the treatments installation worldwide increase exponentially. So these are some of the drivers. First of all, stringent regulation. So WHO want to apply more strict, for example, regulation for organics, for nutrients in the effluents. So they keep it lower. So now if we have standard A50 COD, maybe in the next few years it will become lower and lower. They put a standard on ammonical nitrogen now about 10 or 5, I think in Malaysia. They can further reduce it to lower and lower. So the stricter regulation on the effluent quality drive people to shift from the conventional activated sludge to MBR. Another thing is that high demand of water reclamation. As we are aware, the number of population is increasing. Basically, it means the increasing need of waters, industrial growth as well as the population growth. When you operate your plants, you also need water. On the other hand, the resources of water is depleting. So basically, it doesn't match. So the water shortage then drive people to think about how if we reuse our effluent. Okay, on top of the increasing tap water tariff and the limit of the volume of wastewater supply to industries. When I discussed with Q, actually now some of his clients who has a concern about the limited supply of the volume of the water they can get from the water grid. So they have no option but to go for reuse. Another of a huge driving force for application of MBR in industry is because of the limited space. I will come back to this one. So we need to treat a large quantity of the wastewater at a limited land area. Okay, so that's also the driver. Other than that, we have health protection issue, and then there are some of the industrial wastewater that is by nature very hard to treat using the conventional method. For example, I mentioned here about the pharmaceutical wastewater. It is hard to handle. Why it is hard? Well, you use a biology. We use a microorganism to digest the organics, while actually medicine is toxic to microorganism. So that's why it's not easy if you use a conventional way. Another driver is some of the wastewater. They have a tendency to make to disintegrate the sludge. So basically, the microorganism cannot form a very good flock. For example, here, phenolic wastewater is very hard to treat biologically. And then some industries like food processing industries, for example, they have a variable loadings. For example, in the morning, they do produce a lot of wastewater with very high concentration of COD. While later in the evening, basically there is no production, there is no activity. So at that time, they don't even have wastewater. So that's also a problem if we use the conventional wastewater. Lastly, that one is sometimes we need to have membrane at very low capacity, and application of active sludge is then not feasible. Okay, so how good is the effluent quality of MBR compared to the CAS? This example I take from a report from Torre. So as you can see here, TSS for CAS can go from 10 to 15. If this is for domestic, for industry can go up to 50. COD level normally for domestic we can achieve 40 to 50, but for industry can go up to 150. And for all of these parameters, you see in MBR, they are much lower. Okay, so they are much lower. So it was a big question for the research community at the time when this kind of report is produced, because people think why it's happened. So if you look closely into membrane process, so I give you example of this is a membrane that is maintained by Mr. Chu's company, okay, somewhere in KL. So once a year they do maintenance and then do some cleanings. So this is a picture of membrane that before cleaning. You see here, I make an illustration that as you progress the operation, some microbe will be attached to the membrane surface. Yeah, some of the microbe will be attached to the membrane surface, and in MBR we have to pump the water from outside. Let's say from outside, go inside the modules basically, and then when they have to go inside the module, it has to pass this biofilm. And this biofilm also need food, and it's also consume the thing. So apart from giving a problem to the filtration, it also helps to increase the effluent quality. That is why in almost all reports that compare activated sludge to MBR, they will claim universally that MBR effluent quality is way better than the activated sludge. Okay, so how about the footprints? Okay, I have an issue that we have a limited area in our plant, and then we only allocate some small area in the corner for the treatment of the wastewater. So this is a land layout for application of the conventional activated sludge, where you have basically here the temporary tank, you have a clarifier, we have the aeration tank, and sometimes if you want to process your excess sludge, we have an anaerobic tank here. So when you use MBR, we don't need this one. And then it means that So we can reduce the land requirement by up to 23%. Okay. So how if we face a problem of water shortage? We want to use our effluent. We want to use our effluent to process to the process. Okay. So you see here that if you use activated sludge, okay, you have an aeration tank, you have the clarifier. To be able to reuse, okay, you either need to go first to sand filter and RO to meet the quality, or you can anyway will need to use a pre-treatment for your RO using microfiltration on and ultrafiltration followed by RO. So if we have MBR, okay, we can directly, okay, depending on the purpose, yeah, we can directly use the effluent if the quality meets requirement. Because the quality, basically the one that I saw before, data from thorium membrane, was the quality is actually meet the requirement for showering, for bathing. So we can directly use the effluent without any further treatment, or without pre-treatment, we can send it to RO for reuse purpose. So MBR plus RO, reverse osmosis here, is suitable for plant expansion and new plant due to the smaller footprint, also for the water use. Okay, then you ask about, well, membrane is expensive. Well, you were right if you say it 20 years ago. If you say it now, it's not anymore. Okay, so I take data again from the same review paper that I will share to you later on. This is the capex of okay, this is for municipal wastewater. So you can the unit is in, I think, Chinese yuan, and then this is the cost per if you have a capacity of per cubic meter per day capacity. Okay, you can, what you can see here is on the left side, that is for municipal wastewater, as on the right side, this is for industrial wastewater. What we see here is from, okay, from this one to this one is basically increasing capacity. So if you have, okay, I think I have, okay, increasing capacity. So as you increase the capacity, the investment become lower. And then, okay, on the right side here is the OPEX. The OPEX for MBR. The take from the three images here, I summarize basically here. For industrial wastewater, CAPEX is a little bit higher. It's about 30%. Where I get this number is by comparing this value to this value. Okay, the OPEX for MBR is mainly for the energy, and then we here compare the plant built. This is from, for example, this is 2006, 2014. Compare it with 2015 and to 2018. So the recently developed MBR has a much higher efficient. I think the one that is built in 2020 will be super efficient. Okay, and then the other thing is that the larger the capacity you have, and the lower the specific capex and the opex. So the main things from those slides I can summarize here. So if you compare investment cost of the conventional activated sludge, okay, in average, this is data from a Chinese report. The investment is about 380 cubic meter per cubic meter per day capacity. If you have conventional activated sludge with the tertiary treatments, with UV, with activated carbon, and so on, the cost of investment close to USD 600. And then if you compare it with MBR, okay, the average cost is about 600 USD per cubic meter per day, which basically tell us that if you compare cost plus tertiary treatment, the investment is equal to the investment of MBR. In terms of capex, okay, in terms of operational expenditures, also as you can see here, the efficient MBR already equal the operational expenditure for the conventional activated sludge processes. And then most of the data there published in this paper was taken for the membrane installed before 2018. And new MBR design have significantly reduced the energy costs for aeration. I would then show you some of the videos demonstrating the new type of MBR. For example, the first one, it's called LEAP MBR. Okay, this technology is commercialized by Suez. They use, they call it as sludge flow to enhance the cleaning of membrane. As such, it reduces the energy consumption significantly. So you see here that the air bubbles goes like intermittently with a high flow, and then the membrane can sway to the left and right, vibrate along the process. Okay, in this technology, this technology is the one developed by Alfa Laval from Denmark. They can operate a membrane system fully driven by gravity. So basically, they don't need the permeate pump to take out the treated water from the membrane, from the biological tank. It just uses a simple hydrostatic pressure. As such, it's also minimized the energy consumption of the MBR. You see, this is a permeate going out, and they link it with the flow controller here to be able to control the permeate stream to have a continuous operation. So this technology requires no pump. It's high performance technology requiring no pump. Okay, another one here, this is technology from Huber in Germany that use rotation to also reduce the energy for membrane cleaning using the aeration. This one is actually the video taken for treatment of industrial wastewater. So recently developed MBR is highly energy efficient, and I think by now, if you use the most advanced membrane, the MBR OPEX will be about the same as operational expenditure for activated sludge process. Okay, so next I will give some of the demonstration of how if we compare side to side activated sludge and membrane bioreactor. So when we design activated sludge, we have to operate it under certain conditions so that your microbe can grow well, and then the sludge can be separated well in the secondary clarifier. In doing so, we need to adjust the loading, we need to adjust the concentration of the biomass, we need to adjust the dissolved oxygen, how much oxygen we provide to the system, we need to adjust how long we call it a hydraulic rotation time, and then we also need to form sludge that settle easily. Okay, so these are the parameters that has to be optimized. As such, we will be able to achieve a good condition for growth and sludge separation, and eventually we will have acceptable effluent quality. So when we do MBR, so as you can see here from left to right, the difference only on the second one. So here, instead of having clarifier, we have a membrane system over there, and for the membrane system we install the extra aeration here. The aeration here is for membrane cleanings. The same thing for MBR, because we also use the biology. we also need to adjust the condition that is favorable for growth of microorganism, as well as for membrane fouling control. I will not discuss that one here, but for membrane we also need aeration here to control the membrane fouling to maintain the performance. So I provide you the Excel package. Before I go over there, so what are those favorable conditions? Okay, these are list of conditions favorable for MBRs and favorable for activated sludge process. Okay, for example, food to microorganism ratio is basically a gram of COD divided by, you can see the unit here. For MBR, we have this value, and for conventional activated sludge, we have this value. Okay, for MLSS, for example, MLSS is basically mixed liquid suspended solid, basically the total sludge concentration. For MBR, we can go up to 10 to 12 gram per liter, while for the conventional activated sludge is way lower, like a quarter of it. And you can also see different parameters. So if we look into these parameters, then it gives you also the question, answer the question why we have a better effluent quality in MBR. Because basically this is the ratio of food to microorganism. So basically in MBR, we have more sludge inside the reactor, so more sludge that eat the same amount of the food. That's why the organic concentration in the effluent become less. Another thing is that now that we operated at a very long sludge retention time. Okay, if you don't understand, it's okay. I will show you later on a bit how it works. We also produce less sludge. But at the same time, because we need a membrane in the system, we also have extra cost and an energy cost to operate the MBR. So now here I have the same feed wastewater when I designed this one. First focus on the left here. These are the operational condition of my feed. Okay, in this slide it is example for domestic wastewater. So let's say we have a capacity of 4,000 cubic meter per day. Inlet BOD is 200 milligram per liter. And let's say this is the ideal sludge condition. Our sludge volume index is 100 milligram per gram. So based on the operational data that I saw previously, I will have the outlet BOD of about 20. I will have a sludge concentration about 3 gram per liter, and the sludge age is about 8 days. For MBR, I also take it from the previous slide. So outlet BOD is lower, it's 10. MLVSS is higher, 6 gram per liter, and sludge age is 30 days. Okay. Here I show you the Excel package that you will get from Alvin later on. So basically what you do is, if you have a different composition here, treatment capacity, if you change capacity, let's say to 8,000, then you already see the change here. It's count automatically. All of the calculation is down here. If you have an inlet BOD, okay, I'm treating now the industrial wastewater, so my BOD is 2,000. So then it also gives you what all of the parameters there. And then the parameters to operate the activated sludge is simple. The volume first. Okay, what will be the volume of my reactor? Okay, how much is excess sludge I need to waste? Okay, and how much of the sludge I need to return here, and of course what will be the volume of my reactors. So I will share this one. This is for activated sludge. So now, how if I do exactly the same? I have exactly the same capacity. I have exactly the same inlet BOD. What will be it if I run MBR? So I also provided for you here for domestic wastewater. I have to return this one back. This is 200. This is 4,000. just an example. And also I do it, this is for domestic, and then the CAS2 and MBR2 is for industrial wastewater. So the summary of the result I got from this Excel calculation, I put it in the slide, as you can see here. I do understand if you cannot see it, but no worry, I prepare you the summary here. So what we see from those two tables, in terms of the volumes, when treating the same capacity, we will need about the similar volume. In terms of the quality, of course, we have been discussing MBR is better. Okay, aeration rate, aeration energy, you see here MBR is, okay, 80% higher. Why do we need so high of aeration? Remember that the sludge concentration is high. When you have a sludge concentration is high, means that you have microbe. They can consume more food, but they also need more oxygen. So that is one of the reasons. The second reason is that if I have a membrane, I need the air to score off the foulants. So MBR will consume 80% higher energy, but the thing is the cost for aeration is not much. Okay, you see here I provide you with the link. This link will give us some of the basic calculation of the cost of aeration. It costs about 30 to 50 cents per cubic meter. Of course, it depends on a lot of factors, but if you go for high capacity, it is this one. Okay, the most striking point and the plus point of MBR is when we consider the sludge production. Why it is important? Because of the cost for sludge handling in Malaysia. So this price I got it from Mr. Chu. So I think he is very professional, experience in wastewater treatment. So the number is very reliable. So the cost is 500 to 800 ringgit per ton. And then when you use MBR, you basically produce almost half of the sludge. Okay. So some of the important remark here is that if you use MBR, okay, the plus point is that we don't need to have a clarifier anymore. So we can save footprint. We can also save tax for civil costs. We don't have to build the tank. Okay. But the minus part of MBR is that it requires investment of the membrane. So it's contribute to capex. And then we will have a trade-off between the aeration energy and the sludge handling. But as I mentioned here about the price doesn't really high. So basically, we will be able to have a substantial cost saving because of the MBR can produce less sludge. Okay, enough, Professor Roel, or you call me Roel. We don't manage domestic wastewater, we manage industrial wastewater. So how of MBR in treatment of industrial wastewater? So basically it is applicable to upgrade any existing biological treatment that has been established in industry. For example, in your company now, you have a biological process using activated sludge, or using other type of biological process, trickling filter, moving bed, bioreactors. All of those biological process can be upgraded to form a membrane bioreactor. No questions. Okay. Well, I don't have it. So I do have installation that is not applicable for conventional activated sludge process. If you are in that situation, maybe MBR can help you. Why? Because MBR is, for example, your wastewater is very fluctuative. Yeah, the composition change over time, the capacity, the capacity of the wastewater change over time. Well, that one cannot be treated using the normal way. Okay, well, that one can be handled with MBR because why? MBR is very good in avoiding the issue related to the sludge bulking. So basically MBR said that I don't care what happened to the microbe, you bulk, you don't bulk, you all will be separated. No problem. Okay, so I don't use a biological treatment now because of we produce some of the organics that is persistent. For example, in your wastewater, you contain phenolic compound, you contain pharmaceutical compound, and so on. it's okay. We can try MBR because MBR is very resistant to those kind of chemicals. And if you have a very high COD, well, that's a problem for you because all of the organic will be converted into sludge in the end, meaning that you will have a very high cost for the sludge handling. Maybe MBR can help by also reducing those costs associated with the sludge treatment. And there are so many established reports on application of MBRs in the industries, for example, petroleum, food and beverage, pulp and papers, textile, and so on and so on. If you are interested to go into that, here I link the references that you can go through. First one is the MBR site managed by one of my colleagues, Professor Simon Judd from Oxford University. And the other one here is the link for some of the review paper that summarize the application of MBRs for industrial wastewater. Next, I'll go quickly. So last 1 hour before the presentation, I go through some of the examples. For example, here is the application of MBR in petrochemicals treating the refinery wastewater. You see here, this is the influent refinery wastewater. Okay, for your information, refinery wastewater contain a lot of oils in the form of emulsion. Normally, it's very hard to be treated with a conventional activated sludge. And you see the picture here, a clean, clear, crystal clear of MBR effluents. So how the system is developed. So basically, this is when they run on the day 10, you have about the same between the inlet COD and outlet COD. And then as the time passes, when the more microbe is growing in the system, the COD goes down. With the removal efficiency go up to 86 to 89% of here is BOD removal, and this one is COD removal. It has also been used for food and beverage industries. I just snapped some picture from a technical report provided by this company that apply MBR for treatment of winery wastewater. You see here that it has been implemented already in the large scale. So there's no question about proof of concept, success story. Yes, MBR has a lot of success stories in treating industrial wastewater. I have a last example here for pulp mill industry. Okay, we have the feed composition here. It has a very high suspended solid, 350 milligram per liter, and COD is quite high. It's up to 1500 milligram per liter. But no worry, the MBR could reduce the COD to a level of 30 to 60 ppm, milligram per liter. And in this study, they not only treat the wastewater, they also use it for the process. So you see here, the graph is exactly the same as here. So they use the MBR effluent as a feed directly to RO, and it by using RO, it can reduce the COD below 10. Okay, this is an example for paper mills industries. So next slide, I show you here. I show you the difference between how if I treat the same wastewater, industrial wastewater, one using activated sludge and another one using the MBR. So all the details you can check in the slide later on. These are the summaries. Okay. In terms of the volumes, it's about the same. Okay, so the capacity you can get is about the same. Effluent BOD MBR is much better. Aeration rate, in this case, it's also about similar. So there will be no more investment in terms of aeration compressor. Again, similar to the one for the treatment of domestic wastewater. When we use MBR, we can reduce the sludge production by 80%. And then again, I put it here, the cost for sludge handling is high, 500 to 800 ton per ton. So if you have a waste stream that has a very high COD, you have a very good chance for the cost saving by upgrading the activated sludge system to membrane bioreactor. So some of the important process differences is that the same as for the domestic, in MBR we don't need clarifier, so we can save the footprint and then capex, but we also need capex to buy the membrane, but we will be able to substantially save from reduction in the production of the sludge. So next question is that, so I want to upgrade my conventional activated sludge to MBR. What should I do? Okay, basically this is the secondary, the conventional activated sludge, and this is the MBR. So what should we do? It's simple. We will just need a minor adjustment. Okay, we will need to install a membrane filtration system like this one. What happened to the clarifier then? We can use the clarifier as a membrane tank, like in this example. Here we have a membrane tank. We just convert this clarifier into the membrane tank. We use it to place the membrane. Or we can use it for other purposes. We can increase the capacity of the treatment by combining the clarifier with the bioreactor and place the membrane in the bioreactor. So this is how you actually increase the treatment capacity. What will be the benefit for this one? So the good thing is that we don't have to start from scratch. We can just upgrade what you have now. Increasing what you get is that you will increase the effluent quality. Maybe you can reuse it if the design and the process run very well. You will have close to 80% of cost saving from the sludge handling. And then based on my experience, that you can further increase the treatment capacity by not only by utilizing the clarifier now acting as part of the bioreactor, you can also increase the capacity by further optimize the operational condition. Okay, a good news is, as I saw here, that the price for membrane is declining to a level never imagined in 20 years back. So whenever I present anywhere, people always ask about how about the high cost of the membranes. No, high membrane cost has substantially reduced. You see, by a factor of 12. If you look into the first membrane developed in 1980s, membrane 2020s now, it's not become the cost factor. If you look into the review paper I have listed before, the fractional cost for membrane in MBR is less than 20%. So it's very low. Of course, it is really depend on the capacity, how much you buy the membrane. If you just buy a small area, then the price will be different. Okay, I have a few more slides, don't worry. So in conclusion, you see I have 2 more slides. I have tried to share a good news that application of MBRs can upgrade the conventional activated sludge process because of many advantages that I have discussed before. Okay, those advantages, and because of some of the driving force, like more stringent effluent quality, reuse of effluent, and so on, make the membrane installation and capacity growing exponentially. And then also the new MBR has substantially lower capital expenditure as well as operational expenditures, thanks to those of new patents and recent innovation on MBR development. MBR has been widely used for treatment of industrial wastewaters. There is no proof of concept. All is there. There are many success stories. Some of the success stories I shared to you before for the refinery wastewater, for the food and beverage industries, for paper mills treatment, and so on. And then we can directly use MBR effluent if the quality meets your specification, or it can be combined with the reverse osmosis, as I show you an example of the paper mill effluent treatment using MBR plus RO. Substantial cost saving can be offered for the industrial wastewater by significant low production of the excess sludge. And then we see the declining trend of membrane costs that further increase the competitiveness of the MBR. Oh, my last slide is what will be the recommendation. So here I cannot see what did I write. So what about with my current system? What is that? Sorry, I cannot see it.
Shall I help, Professor?
What I said, what I write first sentence.
What to do with my current system?
Okay, what to do with my current system? Well, depend on who you, depend on who are you. I said, depend on who are you. So I quote. This is a British quote. Okay, there are three things. Okay, if I'm broke, don't fix it. If you have an excellent conventional method, you meet all of the requirement. You don't need reuse. Everything is well. Okay, if I'm broken, don't fix it. You're very happy, good. Okay, another version of us, of people, is that we can also have this philosophy of there is always room for improvements. Well, I know that my system already good, but there must be a way to improve it. So that's another approach. And then another way of seeing things is that prevention is better than the cure. So we don't wait until it's broken and fix it. If possible, we anticipate the problem and do something before the bad thing happen. So what you can do is that I provide you with the Excel tools, so you can do some basic simulation to assess the system you have. Okay, for example, you check based on the calculation you have. Let's say based on the calculation you have a volume of 50 cubic meter. But then in the reality, you have activated sludge or biological system that run at volume of 100. Basically mean you are over design. When you over design, you have an opportunity to increase the treatment capacity. Okay, for example. Okay, and then you can also, okay, now I have my current system. How if I try to upgrade it with MBR, and then you run that calculation from the Excel I provided and see what will be the advantages, how much sludge I can reduce. Okay. Okay. If you want more, then you can send a request to Mr. Chu. Maybe we can help. Maybe you need some professional assessment, a quick one, to see if you can do some small improvement. Because sometimes some people are very specialists, like, for example, Mr. Chu, that has been there for 20 years on wastewater treatment. A few minutes, he already have an idea of how to improve the system and increase the effluent quality and so on. Okay, this one I like it. Money speaks even more loudly. So I have been telling you about what is good, what is bad, all qualitative. Okay, I don't like that one, Roel. Can you do some basic calculation? Yes, we can do, of course. So we have to do a basic, we call it techno-economic analysis, and see what will be the cost saving or the profit, or maybe the extra investment required if you want to upgrade your current system to the MBR. And last but not least, I have this one. MBR is not the only solution. Okay, MBR is not the only solution. Maybe the problem associated with your setup can be fixed and can be upgraded without even upgraded to membrane bioreactor. Okay, with that, I end up my presentation. I hope it's useful to all of you, and it is an honor for me to speak to all of the specialists that has been working in that industry. I will welcome any questions. I'll try my best to answer. Other than that, Mr. Chu will help me. Yeah. Okay. Thank you very much.
No problem. Okay, again, we would like to say a very big thank you to Professor to give us such informative presentations. And I hope that if I have chance, I will make this kind of webinar to all of you, especially to our current clients. Okay, and for those if let's say you feel that it's very informative for you, please type with 555. Then if you want me to do more this kind of things with free for you, you give me 555 in the chat. more than half, 50%, I will do another one in the near future. Okay, in the important is to enhance the knowledge, the operation. It can be many things. For the wastewater treatment, actually is involved of not only the design but also operation. And I would say the operation is very important. It's very important. After you listen to professor regarding to this MBR. It's not like what we think the MBR is very expensive or complicated. Maybe last time, but not this time. Okay, this will be the good chance and a good time to explore this MBR because of this reduction of energy, operation cost, lower capacity or same capacity, not like last time, very much higher capex if compared to the nowadays. And also another the point very important is the reduced excess sludge. The disposal of the sludge is very expensive nowadays. So if let's say you use an MBR at the same time, you can reduce the sludge, you can reduce the cost of the disposal. At the end, actually, you get all these benefits. There's another point I would like to highlight over here. There's many types of MBR in the market. It depends on what type of industry, wastewater you have, or you discharge, or you generate. So it's different types of this MBR. You should use a different different types of wastewater. You should use different types of MBR. Like you have a flat sheet, you have a tubular type, or you have a hollow fiber, and which one you choose. So all this is knowledge and experience, and my professor can help in terms of this. Which this one is very important. Don't just simply just pick one and then put it in at the end, and you face a lot of problem. Okay. Nowadays the MBR also the improvement of MBR can up to gravity. Don't need permeate pump anymore. So it's very actually it's quite impressive. And this one MBR is go to some era which is different from last time. So hopefully we can explore this kind of this new technology and with a lower cost. Okay, so before that, I think there's a couple of question. We go to this Q&A session. I would like to pass this session to Elvis to conduct this Q&A. So, Professor, maybe one by one we go through this question. Is it okay?
Okay.
Okay, thank you, Mr. Chu and Dr. Roy. Okay, so now I will ask the question that brought participant. So the first question is there any possibility of the sludge inside the MBR change to anaerobic, then being transferred as rust?
Okay. It's a technical question. If you have, depending on how you operate the MBR, okay. If let's say the membrane is immersed inside the bioreactor, it's impossible. It will be aerobic. Okay, but if you operate it separately, okay, in the separate tank, maybe it can turn anaerobic, maybe, but most likely not. Why? Because we also have a quick sludge circulation in MBR. So good design should not allow the condition to be anaerobic in the membrane tank. Good design. But bad design might be, because I've seen someone operate MBR fat and batch. So basically they will pump a lot of sludge in the MBR tank and take out the permeate. They concentrate the sludge over there after operation of, let's say, 12 hours. Then they return back the sludge to the bioreactor, to the aeration tank. In that case, yes, it's potentially to have anaerobic condition in the MBR tank. I hope that answered.
Thank you, Mr. Roy. So the next question is from Ahmad Fazli. So his question is, what is the type materials for the membrane?
Okay, there are so many types of membrane available. In terms of the shape, you can have hollow fiber, you can have tubular, you can have plate and frame. Okay, the material, okay, the most common one that is used is from polymer. Okay, the less common one is ceramic membrane. Okay, ceramic membrane is still quite expensive, like probably 20 times more expensive than the polymeric membranes. So I can say almost more than 90% of MBR now, they are polymeric membranes. Mainly, okay, the raw polymer is polyphenylidene difluoride. So it's a PVDF. We also have polysulfone, PSF. We also have membrane with polyacrylonitrile PAN. Those are the three most. Okay. We also there's also a commercial membrane from PE, polyethylene polypropylene membranes. All of those membranes are designed to be hydrophilic, to have a high flux, water flux, and to have a lower fouling. Okay, so those are selection of the membranes, and which one is the best or really depend on the application. I would say personally I prefer the PVDF membrane and a microfiltration membrane for standard MBR personally. So if you ask me what in my opinion, but it really depend on the I think it's case by case basis.
Okay, I think the answer is clear. So the next question is from Muhammad Shahril. So the question is, for the waste that contain high surfactants, how high TOC and can MBR filter this up to how many percent? Means in his final discharge, he don't want to see bubble on the water.
Okay. I have no direct experience treating I think this is laundry or detergent wastewater, yeah. If you're, okay, because we have to distinguish between what is the source of the TOC. If all of your TOC coming from the surfactants, then we need to customize the MBR. Okay. We have to go for a tight microfiltration that can retain the surfactants inside the reactor while being biodegraded by the microbe and can have surfactant free in the effluent. So it's really depend. So can it be? Yeah, the answer is yes, it can be done, but it is depending on the design. But we can help you to design a system that has a bubble free, of course. If you use the standardized MBR and then it contains high surfactants, and then the biodegradation doesn't reach, for example, your TOC level doesn't reach less than 50, most likely you will have surfactants in the end. Okay, there are a different way of looking into this problem. You can design the MBR itself, or you might need to have a post-treatment with RO, and then you can reuse the effluents. Okay, I cannot give you straight answer because this is really case on case basis, and I have to know the composition. I have to know what is the TOC and so on.
Yes, I agree. Maybe I just add on something on this one. Normally, this TOC is depends on what types of the raw waste. If the oil and grease, I think everybody also know below 10 ppm, the oil and grease actually will affect this MBR. So the pre-treatment for this before the MBR is very important, such as a chemical physical process and this aeration. For the surfactant, there's some surfactant is biological, degradable. So it's supposed to be degraded before going to this MBR. The second one is for those the surfactant cannot be degraded by this microbe. Of course, we need to look into the more details in order to get the right MBR this membrane in order to solve the problems. Hopefully, this will answer your question. Okay, next.
Okay, so the fourth question is, the membrane technology normally performing at 75% products and 25% reject. is the MBR contain concentrate reject, or the reject is the one lost or wasps?
Okay. It's the same as activated sludge. You produce, so you have feed, you bring in air inside. So if you look into the balance, you bring in the feed wastewater here, you bring in the air, and you produce effluent, and you produce waste activated sludge. Okay, now you can see from this calculation, for the activated sludge, so if you have feed of 360, we will have to waste about 18 cubic meter per day. That goes to, where is my calculator? 20. Let's go to less than 5% of the volume goes to form the excess sludge. Okay, when you do the MBR, it's 1/3 of it. So it's basically, so from 360, you need to waste about 10. So 100 of a 0.3 percentage of the volume that is converted into the waste excess sludge. So yes, we have concentrate of the sludge, but the volume is about 1/3 of the one produced by the activated sludge. Okay, MBR is not RO. Okay, in reverse osmosis, yes, you can have water recovery up to 75%, and you also produce the concentrate of about 25% of the volume. But in MBR, if you use MBR, it can go as low as below 1% of the concentrate to form the waste activated sludge. Okay, I think that's answered.
Okay. So for the fifth question is, on the ROI, what is the general average ROI when changing from CAS or EAA to MBR?
Honestly, I don't have answer. You can give us your plan and we can calculate for you. We can do some basic calculation and calculate for you. It's really depend on the, okay, if you have activated sludge, and now you want to upgrade it to the MBR. So it's very simple. We need to calculate the cost of the membrane, the installation cost, and so on. And then the income will be from the cost saving from excess sludge handling and from the price of water if you use the effluent for use. So it will be case by case basis, really case by case basis, especially when you treat industrial wastewater. So if you are interested to go just to find out, well, you just email Mr. Chu, and then we'll be able to help you with that. Okay.
Okay. Last few questions. So the next question is, MBR can reduce footprint by 33%. What about the actual size? If we have 100 meter cube per hour influent, is the size can be 30% from 100 cubic meter?
No, what does it mean is that, so if you already have size now, if you already have, let's say 100, what is it, question, 100 cubic meter? Okay, if you already have 100 cubic meter the volume of the reactor. So what does it mean is that now, if you convert it to MBR, you will not need your clarifier anymore. You can just immerse your membrane inside your 100 cubic meter of the reactor, and that's it. And then your clarifier become the excess. So what to do with the clarifier, up to you. If you want to make it as holding tank, if you want to make it as another volume for the reactor, basically means that you can increase more the capacity of your system. Is that clear?
Yes. So the next question is, can the sludge being carried over from the membrane?
Can? Wait, I'm going to read it. Which question you? Which one that you?
Is the one at the bottom there from Ahmad Fazli. Can the sludge
Okay.
carry over from the membrane?
Can be. Wait. Can sludge being carry over from the membrane? Carry over, what does it mean? Well, the sludge will fully retained by the membrane. So it won't pass through the membrane. That's why you have a suspended solid almost zero in your effluent. Sorry, it's raining in my place. I hope the sound quality is still good.
Still okay, sir?
Yeah, your sound quality is still okay. So I think there are a few more questions. So for the 26 from Muhammad Shahril also, rather than direct replacement when the times come, is there any possibility of doing on-site CIP? Of no such CIP, just changing according to lifespan?
Well, very futuristic question, the second one. Is there any possibility of doing on-site CIP? Yes, it can be done. And depending on which supplier you are, or if you are, depending on what consultant you work on, definitely you can do on-site CIP. Personally, I like your second question. Can we just don't do CIP? The answer is yes. But you have to optimize the way you operate the membrane. Okay, I'm in favor of running the membrane without cleaning. So if you consult me, can we run MBR without cleaning? The answer is yes. But for the detail, we have to discuss in the separate session. But personally, I like to operate the membrane without cleaning, without chemicals, without whatsoever, just aeration. It is possible to run that one.
Okay, so thanks for Amirul Afif. So this question is how the sludge produce reduced to 90% when using MBR compared to CS. Both are using activated sludge and biomass will keep producing as long as the microbes metabolize. Please clarify.
Well, that is the question I will ask to my student if I perform the test. Very good questions. Well, it's the 90% there is basically the 90% of so 90% less of the conventional activated sludge. So if the sludge produce 1,000, the MBR produce about half of those. So it's reduced by half. The reason is that we operated the system at longer retention. We call it a sludge age, sludge retention times. So when you operated sludge at long retention time, basically you have higher endogenous respiration. So the cell will eat itself. Instead of growing, instead of producing more sludge when they eat, because the sludge is starving, yeah. You have if you look into the F to M ratio, yeah, the ratio of food to microorganism for MBR is very low. So basically in MBR, we force the microbe not to reproduce. So instead of reproduction, because of the food is less, they will preserve the food inside the cell. Instead of reproducing more cells, they will preserve the food for them to eat. Okay, the logic is basically when the microbe barely survive, they won't be able to multiply. So that's the logic. But the scientific answer is the KD. So decay coefficient for the MBR is higher. Okay, but a very good question.
Okay, Dr. Roy, I think there's last three questions here. The first one is from Miss Li Hui Ling. So she asking that by using the MBR, can it help in reduce the hardness in treated effluent for use purpose?
The answer is no. We cannot. Because calcium and magnesium is in solution, and then if you use MBR, they're so small it will pass through the membrane pores. So the only way is you have to go to RO for the reuse purpose, or maybe you can do pH to precipitate the calcium or magnesium, but relying exclusively on MBR is not possible.
Okay, so is from Muhammad Rashid. So he asked that how frequent MBR need to be replaced 1 year?
How frequent?
How frequent MBR need to be replaced in 1 year?
Well, you can use the same membrane for up to 5-7 years. You just need to do intensive cleaning maybe once a year. So the replacement, so the lifetime of the membrane, yeah, it really depends on how you operate. Okay, if you operate with a lot of cleanings, bed fouling, you do, then the lifetime will probably be less than 3 years. But you operate it very well. There are MBR that has been running for 20 years without replacement of the membrane.
Okay, I think the answer is quite clear. So for the last question is it suitable to use MBR if normally the sludge floating after chemical and physical treatment?
Well, this is the advantage of MBR. You cannot do it for activated sludge, but yes, you can do it for MBR because we don't care about the state of the sludge. As long as it is a microorganism, it will be separated by the membrane. So when you have this kind of problem, it's time for you to actually shift. It is time for you to move from the normal activated sludge to MBR. Because fixing this problem in activated sludge is a headache. I've been doing some of the project about try to upgrade the activated sludge, and then we have the sludge floating, sludge bulking. It's a headache. It's nightmare. So if you have that problem, I will recommend you, not because of I'm the practitioner of MBR, but I want to help. The best way is to go for MBR. Okay.
Yeah.
Okay, very good answer from Professor. I think we can say the Professor is very professional. Okay. Okay, in fact, very thank you to you. I think most of the question you have answered, and I got one answer for the question number 4 from Sharil regarding to this notification, written notification to the DOE if there any change of this MBR. The answer is yes, definitely. Because in the rules and regulation very clearly stated that any change in your plan you have to do this notification. The only thing is you need to do so such a complicated or not. This is the only the question. If let's say you have a minor modification and rectification in this MBR, because MBR we only do the this notification only at this part. So we have to clearly state clearly highlight or stated what is the change in your plan to the DOE will do. And the rest of PE, the professional engineer to certify all this, of course, have to. You have to. You have to let the PE professional engineer to sign to and chop on this schedule number 3 and the schedule number 2. Okay, hopefully you answer your question. Yeah.
Okay, so
our side here as a Spectra, I feel that we'll be able to give you this kind of services. And anytime if you need, you have this intention or plan to expand or you want to recycle your water, even though if you want to have this better water quality, please look for us. We are ready for you. with these professors, this kind of support and knowledge, I believe and we believe that the problem will be solved easily. Okay, is there any questions? Any more questions? It's about just now we start from 3:05. Now it's 4:30. It's about 1.5 hours. And another good news is that I saw a lot of 555. Yeah, so it's very supportive from you all. Yes. Okay. I committed. I will do another this webinar for you in the near future so that everybody can get these benefits from here from this webinar. Okay.
Okay, so thank you again for Dr. Roy and also Mr. Chiu and also all the participants that joined our webinar today. So officially we will close our webinar. So thank you for the joining and have a nice day.
Hello. Okay. If let's say that your company you need a private or personal sessions on this MBR side, actually you feel free to contact us. Even though you can contact me or contact Elvis, then we can pay a visit to you and then we can have a one-to-one session on this matter. Okay. Thank you very much, everybody. Thank you.